3-2, solving systems inequalities by graphing. So this is exactly what it says. We're going to solve systems inequalities by graphing. There's actually nothing new here besides, hey, put all the ideas together and graph. So let's just do some examples. This is the best way to do this. So this first thing here, they want us to graph these two. So let me graph that one first. Right, y-intercept is 5. Slope is negative 2x. Remember, we're going to go negative 2 over 1. So down 2, right 1. Down 2, right 1. Down 2, right 1. Do that a couple of times because I can't graph very well on this stuff. It is a solid line, so I'm going to connect it. Nice solid line. That's supposed to be a line. Again, oh, that's bad. That's embarrassing. Anyway, that's my line. I'm going to leave it because I can't do anything else. And this next one here, just graph this next one. So this is y is greater than negative 1/4 of x minus 6. So negative 6, my y-intercept down there. Negative 1/4, so I'm going to go down 1 over 4. 1, 2, 3, 4. Down 1 over 4. 1, 2, 3, 4. You actually go the opposite way too. Left 4, up 1. Same thing. Kind of like that. Now this one is dashed. Or dotted. That's actually a lot better. So I get something like that. They're going to cross right here, but eh. Now I got to shade it. Now again, the shortcut is, it's in proper notation, so I can just follow it. Less than means below. Greater than means above. If you want, you can pick a test point and see if it's which way it is. But honestly, the easiest way is this. Below. So this one's below. So I'm shading all this. And then this one is greater than, so it's above. Here you're going to shade, I'm going to cross shade it. So you're going to shade all the above. And your answer is where they both shade. So my answer right here is this part. Where they're both shaded. And that's the idea. That's the lesson. So let's do a few more. Look at this next one. Let's practice some of our old favorite graphs. It's absolute value graph, right? So notice it's a basic one, so we're going to start at 0. It's solid, so it's going to go like 1, 1. So like this. And like this. Greater than means above, so you shade above it. So it's going to be kind of, if I was going to shade it, it would be kind of like that. So that's that graph. Now the next graph, this one's another line, so I'm going to go plus 5. Slope is 4/3, so up 4, right 3. Positive. So up 4, right 3. Dotted line, dashed line. I do dash line, it's all better than I could do a straight line. Like that, and then less than, so shade below. So below this will be like all this stuff here. Including this part. Okay. So my answer again with both shade, highlight this time. Right. Oh, that's supposed to be highlighted. There we go. Right there. That looks disgusting, but that's the answer. Alright, so again, just graph both, shade both, and then where they both cross shade is your answer. Let's do a couple more. This time I'm gonna add a little twist to it. So find the coordinates of the vertex of the triangle formed by each system. So we're gonna have to find points of the triangle once we draw this. So we'll start off the same way. Let's draw each one. I'm gonna do different colors. So this one in blue. So plus 1. Slope of 2, so up 2 over 1. Up 2 over 1. I guess it looks like this. Now, you'll see why I'm going to do this in a bit, but this is y equals 2x plus 1. Again, you'll see why I'm doing that in a second. Now the next one, y is less than or equal to 8. So remember the way that works, you go to where does y equal 8 at? Right here. And you follow the tally mark, so it should look like this. This is y equals 8. And I'm below this. I'm not going to shade to the very end, but basically I'm all below this. And then this one is greater than. Yeah, so I'm above this one. So it's me in here somewhere. And the bottom one here, 4x plus 3y equals greater than 8. So again, this one I got to put in the proper notation. I got to get y by itself. So y equals mx plus b form. So subtract that 4x. So 3y is greater than or equal to negative 4x plus 8. Divide by 3, divide by 3. Oh, that's not going to be nice. Oh, that's not good. So 8/3. So like 2 2/3. Yay. Man, why can't it ever be easy? So 2 2/3 right there. And then from there I'm going to go down 4 over 3-ish. Right there. So then connect it. It's going to be something like that. This one's also solid. And then shade above. So here's a triangle that they wanted. So that's my solution. Right now, but they added a little twist here. They wanted you to figure out where the endpoints, where these all hit at. So it's actually a lot easier than it seems. So if you want this point here, all you gotta do is solve this equation. Like, I actually know what the y is. It says y equals 8. So that part's done. Just plug it in. Y equals 2 times... Oops, did it the wrong way. Plug in the 8 for y. Minus 1, minus 1. 2x equals 7. Hey, let's continue the theme of decimals. X equals 3.5. So that point right there is going to be 3.5 and 8. Not the worst thing in the world. If you want this point right here, this equation and then write down is y is 4x plus 3y equals 8. Right? So I got to solve that with this red line here, which is y equals 8. So all we're going to do is plug it in. I know y equals 8, so I'm going to plug that in. I get 4x plus 24 equals 8. Subtract 4x equals negative 16. X equals negative 4. So that point right there should be negative 4 and 8. Again, I just solved the two colors basically right there. Get those two equations, solve them. And those have been kind of easy because you had y equals 8. So you knew one of the answers. All you had to do was plug it in. This one's going to be tougher because my equations there are 4x plus 3y equals 8. And right here I have y equals 2x plus 1. So I have to solve for both of them. Easiest way to solve it, substitution in this case. I already have y equals 2x plus 1. So you plug it in. 4x plus 3 times 2x plus 1 equals 8. Solve. So 10x equals 5, x equals 1/2. And then you plug it in, you'll get 1/2 and some number. I'll plug it in real quick. 1/2, 2. 1/2 and 2. That was actually pretty decent. Yeah, so that's how you find endpoints. If you ever want to find endpoints, this is solving equations, right? If I want to find where these two things cross, how do you find where they cross? To meet each other. So is this elimination substitution? Anyway, let's move on. That's the same idea. We're going to skip that. We're going to go down to an application problem. So the last thing we're going to do, a nice application problem. It relates to inequalities. So Ramir uses his spare time to write a novel and to exercise. He budgeted 35 hours per week. He wants to exercise at least 7 hours per week, but no more than 15. He also hopes to write between 20 and 25 hours per week. Write and graph a system that represents this situation. So we have a couple things going on. He wants to spend time writing a novel, so let's put novel as X and exercise as Y. First thing says he has 35 hours per week. So if you add that novel plus exercise has to be less than or equal to 35 hours. That's the most he could spend. He wants to exercise at least 7 hours per week. So X, he wants that to be greater than or equal to 7. But no more than 15. So X also has to be smaller than or equal to 15. If you want, you can combine those two as in like this. But it doesn't really matter. He also hopes to write between 20 and 25 hours per week. So his writing, his novel. Novel was X. Y. I apologize. Sorry. Why did I mix it up for? He also hopes to write between 20 and 25 hours per week. So X is between 20 and 25 hours per week. So now we have our equations. We have this equation, we have this equation, we have this equation. I'm going to start off with these bottom two first. Those are the easier ones. So you want y to be between 7 and 5. So where's y is 15? Y equals 7 right here. Y equals 15. My graph doesn't go that far. Let's say up here. I'm going to be between these two. So shade them inside. X is between 20 and 25. Yeah, my graph doesn't go that far. So 20 and 25 are, let's say, over here. So right now I'm in this little thing right there. Now we gotta solve the top part. Gotta be able to graph that. So subtract x from both sides. Get y by itself. Y is less than or equal to negative x plus 35. Oof. This graph was not correct. So there's 35. Let's just say that. I'm gonna go down 1 over 1. So it's gonna be kind of like this. It might be less than that. So my answer is actually gonna be in this little region right there. So that's the situation you can work on. So you can pick anything you want from there. So they ask you, oh, give me one example. You just pick any point from in that little section there. That'll be the answer. So there we go.